So this video is for assignment number 5 in our unit number 9, which is on sequences and series. It's a unique video because it's a unique lesson on summation notation, which looks like this. It looks a lot more complicated than what it actually is. Summation notation, just to point a few things out, the number down here is called the lower limit. The number on top of the sigma, this is the Greek letter sigma, the number on top is called the upper limit. And the formula that's after the summation notation is always going to be an explicit formula. And so this is what this would look like. It's simply a different way of writing the sum of a bunch of numbers. Here's what it means. The first term that we're going to plug in, we're going to start by plugging in the number 1 because n starts out being number 1. And I'm going to plug 1 into this explicit formula. So if n is 1, 3 times 1 is 3, plus 5 is 8. Which means the first term in my series is the number 8. And I'm going to keep plugging numbers in. Like for example, I started with 1, now I'm going to go up to 2. And if I plug in 2, 3 times 2 is 6, plus 5 is 11. Then I would plug the number 3 in. 3 times 3 is 9, plus 5 is 14. Then I would plug in the number 4. 3 times 4 is 12, plus 5 is 17. And this is going to continue, and I'm going to keep building a bunch of numbers here until I get to my upper limit, which is the 40th number that I would plug in for n. So if I plug in my last number, 3 times 40 is 120, plus 5 is 125. So this series, which is denoted here with our summation notation, can also be written as 8 plus 11 plus 14 plus 17 all the way up to plus 125. And if we want to find the sum of this series, then we're going to use our formula that we talked about in our previous assignment, which is the number of terms divided by 2, and then our first term plus our last term. So in this particular example, we know that we have 40 terms. We started with the first term, then the second term, the third term. This would be our 40th term. So it's going to be 40 over 2. And then our first term is 8, plus our last term is 125. So 8 plus 125 is 133. 40 over 2 is 20. And if I take 20 times 133, it's going to give me 2,660. So that means that this series, which is denoted here in summation notation, is 2,660. So here's what I'd like to challenge you with. I'd like to challenge you with this particular series, which is in summation notation. And I'd like for you to pause the video and see if you can figure out what the sum of this series is. If you have done that, then hopefully you've done something like this. If I plug in 1, which is my lower limit, I'm going to plug in 1 for n. 1 minus 1 is 0, times 6 is still 0, so my first term is going to be 15. And then I'm going to plug in 2 to get my second term. So that's going to be 15 plus 6, which is 21. And I can keep doing that. I really wouldn't need any terms except the first one and the last one because I know it's an arithmetic series. So if I plug in 25, 25 minus 1 is 24. 24 times 6 and then plus 15 gives me 159. And if I want to find the sum, I would take the number of terms, which is 25, divided by 2. And then my first term is 15. My last term is 159. And so I would take 15 plus 159, multiply by 12.5, and I believe that's 2,175. So if you didn't get that, hopefully you were able to figure out what went wrong so that you don't mess up maybe on the next example. So let's take a look at the next example and see if we can figure this out. Something different happens with this particular summation notation, and I want to go through it with you. I want you to pay attention to this because this is where a lot of people mess up. The reason why this is different is because it doesn't start with the number 1. We might have an infinite series that we can find the sum of, but maybe we only want to add the numbers from 8 through 28, the 8th term through the 28th term. And so in our formula, when we normally take the first term plus when we have a formula that looks like this, the number of terms over 2, and we take our first term plus our last term. In this particular example, our first term is actually going to be the 8th term, because that's the number that we're starting with. And so we'll just have to make that adjustment when we get to this formula. But let's first look and see if we can find the information that we need here. The first term that we're going to use, which is actually the 8th term, is the one that we're going to use when one that we're going to find when we plug in the number 8. So if I plug in 8 here, 8 minus 1 is 7, times 4 is 28, plus 7, that's 35. And I could find the next term by plugging in the number 9 and 10 and so on. I'm going to get a bunch of numbers, which I really don't need for my formula. I just need the first one and the last one. My last term I could find by plugging in the number 28. And if I plug in the number 28, 28 minus 1 is 27, times 4 plus 7, I believe that is 115. And so using my formula, I'm going to take the number of terms and divide it by 2. I'm going to talk about that here in just a second. The first term that I'm going to use is 35, plus the last term is 115. What really confuses some people, or what some people forget, is it looks like well, first of all, some people would say 28, because usually it's the number, if we start with the number 1, it's always the number on top that we plug in here for the number of terms. Then a lot of people would think a little bit more, and they would know that you have to subtract these first few terms because we started with the 8th one, not the first one. And a lot of people would put down 20 terms here. But there actually aren't 20 terms. There are 21 terms in this sequence. Because we're only subtracting the first 7 terms, we're using the 8th term. That makes sense, and it's in line with what we did in our first examples, because even though we put down 40 here because there were 40 terms, 40 minus 1 is actually 39 terms. So you can think of it like this. You take the upper limit minus the lower limit, but then you always add 1 to get the number of terms. Same thing with this example. We had 25 terms altogether, but 25 minus 1 is 24. And so we always have to remember that we're going to take 28 minus 8, but then we're going to add 1. 28 minus 8 is 20, but there are actually 21 terms in this sequence. So we're going to take 21, divided by 2, which is 11.5, and 35 plus 115, I didn't do this one ahead of time, that would be 110 plus 40, which is 150, and 11.5 times 150. I'm going to have to use my calculator here real quick. I should really do these things ahead of time. 11.5 times 150 is equal to 1,725. And so that would be the sum of those 21 terms in that sequence. So let's work on going the opposite direction. Let's start with a series that is not in summation notation and see if we can put it in summation notation. So if you remember in our last lesson, we talked about allowance, where you could get a $10 allowance and then the next week get 12 and then 14, all the way up to the last week of the year, get an allowance of $112. Let's just simply put this in summation notation. If we did that, my lower limit, I'm just going to start with the first week, and I'm going to go all the way up to the 52nd week. But then I want to put a formula here that, if you remember, is an explicit formula. This particular example here starts with 10, but I'm going to add a common difference, which is 2, n minus 1 number of times. And so that's what this would look like in summation notation. Let's do an example where we do two things. We're going to write this in summation notation, and then we're going to actually find the sum. So this particular example is going to look something like this. We're going to let 33 be the first term, and we're going to have to figure out how many terms there are here in a little bit. But our formula is going to be this. We start with 33, and it looks like we add 7 n minus 1 number of times. Remember, this is the explicit formula for an arithmetic series or sequence. The question is here, what term number is that? We know that this is our first term and our second term and our third term. How do we find that term number? Well, if we use this formula, 33 plus 7 times n minus 1 eventually gives us 257. And so if we solve this equation, if I could subtract 33 from both sides, I'll have 224 is equal to 7 times n minus 1. If I divide by 7, 32 will equal n minus 1. And if I add 1 to both sides, this is actually the 33rd term in our sequence, which means our upper limit is going to be 33. And then we can actually find the sum because we know that our number of terms is going to be 33 minus 1 plus 1, which is 33 terms divided by 2. And we're going to take the first term, which is 33, plus the last term, which is 257. And if we do that, I believe we're going to have 4,785 as our sum. All right, let's take a look at one more example. And again, this might be a good time to just pause the video, see if you can get this one before I go over it with you, keeping in mind that this 100 here is not the term. This is the 100th term here. It's not the actual term. So I want to find the sum of 100 numbers, starting with 150, then 152, then 154. I just simply don't know what this last term is. And so that's going to be the challenge here. Let's start. If you want to pause your video now, it'd be a good time and see if you can find what the sum of that series is. Assuming that you've done that, let's continue here. This is going to be, if I start with 1, I know the upper limit is going to be 100, and I know my explicit formula is going to be 150 plus 2 n minus 1 number of times. And if I use my formula for finding the sum, I'm going to take 100 terms divided by 2. I know there are 100 terms here. Then I'm going to take my first term, which I know is 150, plus my last term, but that's what I don't know right now. So in order to find that, I'm going to use this explicit formula. It's 150 plus 2 times 100 minus 1, because it's the 100th term. So that's going to be 150 plus 2 times 99. 2 times 99 plus 100 is 348. So the 100th term of this sequence is going to be the number 348. And so I can put that in here for my formula. Number of terms is 100 divided by 2. That's 50. 150 plus 348 is 498. And if I multiply those together, the sum of all of these 100 numbers is going to be 24,900. So those are the examples that you should have in your notes, and hopefully this will be a good start to working on your homework assignment. Remember, it's assignment number 5, and we will see you tomorrow.